Good day. So today I'm going to show you the basics of algebra from the basics, actually going upwards, right? So let me start with this. There's what you call a binomial and there's what you call a trinomial, right? So a binomial is something like this. This is what you call a binomial. Why is it a binomial? It's because it has got two terms, but we are seeing four things. So how do we know it's two? Alright, because we're seeing 1, 2, 3, 4, right? The thing is, addition and subtraction separate something, while it's multiplication and division makes it one. So for instance, if you see these two stuff, these two are separated, so it's one term, so this is two terms. While this one is not two terms, this whole thing is one. The reason why is because multiplication makes two things one, right? So if we have something like this, for instance, these three things are one because multiplication makes it one. They're all multiplying each other, so they are one. So since this one is multiplying each other, it's one term, and this one is multiplying, right? This one's multiplying each other. 2 and y are multiplying each other, so it's one term, right? So we have two terms here. So this is a binomial, and this is what we call, let's say we have something like this. This is a trinomial because we have one term that multiplying, right? One term multiplying and one term here. So this is three terms in total. So this is a trinomial, right? Alright, so just to emphasize terms, let's just say we have something like this. How many terms do we have here? Well, we have three terms. Reason why is because this is one term, of course, right? And it's separated by the addition sign. This is one term, the multiplying. This also is one, even though there's a minus inside, but it's inside, it's not outside. So there's brackets between two and this stuff, right? So between this two and this stuff, there's brackets. So it means they're multiplying each other, right? So bracket means multiplication. So when you see bracket, it's multiplication. So it means it's one term, right? So hence we have three terms in total. So let's talk about multiplying something like this. So if we have anything in the form of, let me just put in numbers first. So if we have something like this, right, it's similar to this rule. So the rule says when we have something in front like this, we have to first multiply a by b. When we're done, we now have to multiply a by c, right? So memorize this stuff if let's say you don't know it. So it's the same thing we have to do. We have to first multiply 2 and x. Then when we're done, we're going to multiply 2 and 2. So what is 2 times x? 2 times x is 2x. Then we're going to have 2 times 2, right? 2 times positive 2, because this 2 there's a plus in front. And this 2 is positive. So positive 2 times positive 2. It's positive 4. So this is the answer of this stuff, right? Let's go further. Let's say we have something like this. So we still want to multiply them the same way, right? So what we're going to do here is we're going to say 2 times x, then, okay, negative 2 times x, then negative 2 times negative 1. So negative 2 times x is negative 2x. Then we're going to have negative 2 times negative 1, which is positive 2. This is what we got. So negative 2 times x, negative 2x. Then negative 2 times 1, negative 2 times negative 1. Because we have to consider the sign that is in front of the number, right? So negative 2 times negative 1 is positive 2. Let's go to another level. Alright. So this is not difficult at all, right? You can pause the video and attempt it, and let's see if you get it. Alright, so negative 2 times x is negative 2x, right? That's what we're doing, right? We're first going to multiply this, right? Then after that we will multiply this. And then from here, when we're done, we'll now multiply this. Then after that we'll multiply that. So negative 2 times x is negative 2x. Then negative 2 times 1 is negative 2, right? Negative 2 times positive 1 is negative 2. And then here, negative 3 times x is negative 3x. then negative 3 times positive 1, negative 3. Then now we're going to have to group the like terms. So when we group the like terms, right? So like terms, what are like terms? Like terms, something must have the same letter with the exponent, right? The numbers can be different. For instance, something like this, 5xy and 4xy. These are like terms because they have exactly the same letters, right? Even if the order is different, it's still the same thing. For instance, if we have 5xy and maybe 2yx, because the letters are exactly the same, the order doesn't matter, so it's still like terms, so we can just rearrange it in alphabetical order and add them. What about this 2 stuff? What about 5xy? Let's say xy squared and 4x squared y. Well, the letters are the same, but they're not like terms because here it's x and here it's x squared. Automatically it's not like terms. Here's also y squared and here's y, so it's not like terms, right? Similarly, if we have something like this, even though the letters are the same, it's still not like terms because this is x squared and this is x, so the letters must be the same and their exponents must also be exactly the same. If we want to add them, we can multiply them, but we cannot add them if the exponents are not the same. So like terms, this one has x, this one has x, right? These two are not like terms because this one has x, this one doesn't have x, right? So we're gonna group them. So we're gonna take 2, we're gonna take negative 2, right? And then I have to take this together with the sign that is in front of it, so it's gonna be negative 3x. Then I'm gonna take this 2 together with the sign that is in front of it, so it's gonna be negative 2. Then I'm gonna take this 3 together with the sign that is in front of it, so it's gonna be negative 3. Now negative 2 minus 3, whenever the signs are the same, you just add the number. So this is gonna be 5, right? 5x, and then the sign of the bigger number wins, but about negative, so it's obviously gonna be negative, right? So for instance, let's say we have minus 8 plus 2. If the signs are different, we subtract the number, so we'll say 8 minus 2, which is 6. Then the sign of the bigger number wins, so the answer is minus 6. Or if we have something like this, minus 5 minus 3. Since the signs are the same, we're going to have to add this number, so 5 plus 3 is 8. Then the sign of the bigger number wins. Another example, let's say we have, let's say minus 8 plus 10. Right? Since the signs are different, we're going to have to subtract them. So 10 minus 8 is 2. And then the sign of the bigger number wins, which is positive, right? Positive belongs to 10, so the answer is positive 2. Last example, let's say we have something like 8 minus 12. Well, of course, this one is positive, this one is negative, so we're going to have to subtract them. So we know that 12 minus 8 is 4. Then the sign of the bigger number wins. Alright, so I deal with this in another video, right? So now here, minus 2 minus 3, since the signs are the same, we add them, so it becomes a 5. So the sign of the bigger number wins. So this is our final answer. Here is another one. Let's say we have 2 and we have, let's say we have this stuff. What we do here is we still do the same thing, right? Negative 2 times x is negative 2x. Negative 2 times positive 1 is negative 2. And then 5, right? Positive 5 times x is just positive 5x. And then positive 5 times positive 4 is positive 20. And then we take the number, the like terms. So we'll take this 2x, and then I take this 5x together with the sign in front of it, so 5x. And then I take this together with the sign in front of it, which is negative 2. Then I take this together with the sign in front of it, right? Then minus 2 plus 5, since the signs are different, let me subtract the numbers. So 5 minus 2 is 3. The sign of the bigger number wins, which is a positive, so positive 3x. Minus 2 plus 20. Well, since the signs are different, let's subtract them. 20 minus 2 is 18. The sign of the bigger number wins. So there we have it. Alright, one last example before I go. I move to another level. Let's say we have something like this. We're just gonna distribute, so it's gonna become 2x. and then we're going to distribute. It's going to be negative 2. Then here, positive 5 times x is positive 5x. Positive 5 times negative 1 is negative 5. Right? Here, negative 2 times negative 1 was negative 2. So that's what we got there. Then we group the like terms. So we're going to have 2x plus 5x, because I take the 5 together with the sign in front of it. So notice I didn't put a minus because there was a minus there. Nope, I take I put a plus because there was plus in front of 5. So I take 5 together with the sign in front of it. And then now I take this 2 together with the sign of it. Then I take this 5 together with the sign of it. So there I've grouped them. 2 plus 5, of course, 7, right? So 2 apples plus 5 apples, 7 apples. Then here, minus 2 minus 5, since the signs are the same, we have to add them to become negative 7. Then the sign of the bigger number wins, but they're both negative, so obviously there we have it. Here is the next level. Let's say we have something like this. So whenever we want to multiply this is the same situation as, let's say, a plus b. Okay, let me just do something a little bit different. Let me use something different. So when we have something like this, what we have to do is we have to multiply this, right? We have to multiply this 2 first. Then when we're done, we multiply this 2 first. When we're done with that, now we have to multiply this 2 and this, right? So it's like we take this, we multiply by everything in the bracket. When we're done, we now take this and multiply by everything in the bracket. So it's that simple. First we take this, we multiply by everything in the bracket. When we're done, we now take this and multiply by everything in the bracket. Right? So that's what we have. So let's apply that rule. Let's make it applicable. So here we're gonna have to take x and multiply by everything in that bracket first. So x times x is x squared. Let me use another marker. So here we're gonna have x times x, which is x squared. Then we're gonna say x times 1, which is x. So notice I'm taking this x and I'm multiplying by everything in that bracket. So first I multiplied by x, then I multiplied by 1. When I'm done, I now take this one. I now also multiply by whatever's in the next bracket. So 2 times x, which is 2x, and then 2 times 1, which is 2. And then from here I group like terms. So notice x squared doesn't have a like term, so I just write it down. And then x and 2x are like terms already. They're already grouped, so I don't need to regroup them. So what is x plus 2x? Apple plus 2 apples. It's just 3 apples, right? And then this doesn't have a like term, so I just put it down as it is. Then there's no way of going further here because all these are not like terms. So this is where it ends. So this is what we call multiplying a binomial by a binomial, right? Here is another example. Let's say we've got x plus 1, and here we've got x minus 2, y plus 1. So now I'm multiplying a binomial by a trinomial. So this is what I'm going to do. So remember, what we have to do is we have to take this and multiply by everything in the next bracket, right? So we'll take this and multiply by everything in the next bracket. When we're done with that, we're now going to take this and multiply by everything in the next bracket. So let's do that. So first we're gonna take this x and we're gonna say x times x, which is x squared, and then x times negative 2y is negative 2xy. So when we're multiplying different letters, they just mix up, right? If we have x times y, it becomes xy. But if we have x plus y, they're not like terms, they can add. Everything can multiply, but not everything can add. For something to add, it has to be like terms. But in terms of multiplication, yes, it can multiply. So we're going to now say x times 1. What is x times 1? Is x, right? And then we're done with this. I multiplied x by everything in the next bracket. Now let's go to 1. So I'm going to say 1 times x, which is just x, and then 1 times negative 2y, which is negative 2y. Then 1 times 1 is just 1. And then from here I group like terms, so it's going to be x squared, and then this is going to be minus 2xy, right? There's no like terms for it, and x squared there's also no like terms for it, so I just wrote them. And then now x and x are like terms, so I don't have to regroup them, they're already like terms. So what is x plus x? X plus x is 2x, right? X times x is x squared. If it was possible to say apple times apple, it was going to be apple squared. But now x plus x is the same as apple plus apple, which is 2 apples. And then now we're going to have negative 2y there, right? There is no like terms for it. And we're going to have plus 1. So we can't go further from here. None of them are like terms, right? For example, here is x squared and x. The exponents are not the same. Here it's xy and x. Well, it's supposed to be xy for it to add, so it can't. Here it's xy and y, so we can't add them. So yeah, that's what we have there. Alright, let's say you're given something like this. Well, what do you do in this case? This squared means it's the same as this times this, right? Similar to this stuff, if we have 5 squared, of course it's 5 times 5. So this squared is the same as this bracket times this bracket. So we're gonna apply the same rule. So we're gonna have to say this times everything in the bracket. When we're done, we now say this times everything in the bracket. So x times x is x squared. Now multiplying this by whatever's in that bracket. So x times x is x squared. And then x times 1 is x. Then from here, positive 1 times x is still x. Positive 1 times positive 1 is still positive 1. And then from here, x squared, then we have x plus x. Since they're like terms, we can add it, so it becomes 2x. And then here we have plus 1. And this is your final answer. Here is the last one. So now we have it as cubed. So it's the same as x plus 1, and again x plus 1. So my advice is always deal with the last 2 brackets before the first one. So we're going to have to deal with this first, so that we can make it 1 bracket. When we make it 1 bracket, it will be as though it's now 2 brackets. So let's just do that. So we're going to have x plus 1. So we're not touching it. We're just going to leave it. And then now here we're going to have to do this. We're going to have to say x times x, which is x squared. X times 1, which is x. 1 times x is still x. And 1 times 1 is 1. And then from here we can add like terms. So x squared. So x plus x is 2x. Then plus 1. And then from here, now we made it 2 brackets. Now we can apply what we know. So we can take this and multiply everything. When we're done, we take 1 and now multiply everything. So first we're going to take x and multiply it by everything. Then now we're going to take 1 and multiply by everything. So let's start with x. So x times x squared is x cubed. Because here's an invisible 1, here there's a 2, so they add up. Whenever you're multiplying something with the same basis, right? If the bases are the same, you add the exponents. So if it's a cubed times a5, it's going to be a3 plus 5, which is 8, right? So if the bases are the same, you multiply the exponents. But if it was addition, we cannot add it because it's not like terms. So x times x squared is x cubed. X times 2x is 2x squared, because notice exponent 1, exponent 1. So since x is the same as x, we have to add the exponents and it becomes a 2. And then from here, we're going to say x times 1, which is just x. Now we're done multiplying x. Now let's multiply 1 by this bracket. So we're going to say 1 times x squared, which is x squared, right? 1 times x squared is x squared. Then 1 times 2x, which is 2x. 1 times 1, which is 1. So there. Now we have to group like terms if they're not grouped. Alright, well, they were not grouped, so here we have x cubed. There's no like terms for x cubed. Now let's check 2x squared. Let's check x squared. Well, there is a like terms for it, so I'm going to bring it closer. I took it together with the sign in front of it. And then now let's check x. So there's no other x squares, right? So let's check x. So I'm going to write down x. And let's look for another x. We've got 2x, and then we have plus 1. So now I grouped like terms. So x cubed plus 2x squared plus x squared is 3x squared, and then x plus 2x is 3x. And there we have it. We can't go further from here.